Hello, today's lesson is on 1.4. Arithmetic sequences. An arithmetic sequence is a function whose domain is the positive integers. For example, it's going to be like 1, 2, 3, 4, and so on. It is a sequence, also known as a list of numbers whose consecutive number have a common difference. For example, if you have the pattern or sequence 3, 8, 13, 18, and 23, and so on. From 3 to 8, you're going to add 5. From 8 to 13, you add 5. Add 5. Add 5. So that is known as a common difference. Of 5, also known as D is equal to 5. Now we have two types of formulas here. We have one type of formula is explicit formula. For an arithmetic sequence. And that formula is A of n. Now, when I say A of n, that means the number term. So like that will be A1, that's A2, that's A3, that's A4, and so on. So A1 is going to be the first term plus the common difference times n, which is the number term, minus 1. Now, that is the general formula, where A of n equals the nth term of the sequence. A1 is equal to the first term in the sequence. D is going to equal the common difference. And n is going to be the number term. And we will do an example of this. So that's one formula that's explicit. The next formula is going to be called the recursive formula. For an arithmetic sequence. Now on the recursive, you have to know the number before. Now on the explicit, I can ask you, oh, what's the 100th term? What is the 2000th term? On the recursive, you're not gonna be able to have that luxury. Now on the recursive, basically in order to find the 5th term, you have to know what the 4th term is. In order to find the 4th term, you have to know what the 3rd term is. So on the recursive formula, they have to give you the first term or at least one of the terms. So here I'm going to give you the first term. And then the formula is going to be a n minus 1, which means the previous term, plus the common difference. And this is for any term greater than 1, which is any term after the first term. A of n is still going to be the nth term. A1 is still going to be the first term. D still represents the common difference. N is going to be the number term. And a n minus 1 is going to represent the previous term. All right, so let's go into some examples. We want to remember our formulas. So this is explicit formula, and this is the recursive formula. So we are given the sequence 2, -8, -18, -28, -38. So let's see our common difference here. To go from 2 to -8, it's going down. It's actually going down by 10. And then from -8 to -18, that's -10, -10, -10. So that is your common difference. So my common difference is going to equal a -10. Now your A1 is your first term. A1 is going to equal 2 in this case. So first, I want to find out what the explicit formula is. And the explicit formula has this equation, AN equals A1 plus D times N minus 1. I'm not asking for a specific term number. So this is A1, this is A2, this is A3. I'm not asking you for any of the specific term numbers. So you don't know what N is. So you leave N in the problem. I know what A1 is. A1 is the number 2. D, that's the common difference. That is a -10. And like before, I don't know what the N is. Now you can leave your answer like that. However, on the assignment, it's going to have you simplify it. So I'm going to go ahead and I'm going to distribute the -10 inside. So we have a 2. -10 times n is going to be a -10n. -10 times -1 is +10. And then to combine like term, 2 plus 10 is 12, and nothing goes with the -a10. So the explicit form is going to be a -10n plus 12. Now let's find out what the recursive formula is. Now the formula for the recursive formula was they have to give you what the A1 is. And then it's going to be AN minus 1 plus D. So what I'm going to do here is I know what the A1 is. The A1 is this number 2. So I'm going to erase A1 and I'm going to put the number 2 there. AN minus 1, I don't know what N is, so leave it there. Plus D. The D is a -10. So I'm going to erase D and put a -10 there. And I'm done. We are done with that problem. What if I ask you to find the 54th term in this sequence? Now you are definitely not going to want to use the recursive formula, because if you use the recursive formula, you have to know what the 53rd term is. Then you have to know what the 51 term is and the 50 term is and so on. So I'm going to use the explicit formula. And right here, when I ask you for the 54th term, I'm basically asking you, this means N equals 54. So I'm going to use this formula. So AN equals negative 10N plus 12. So A54 equals negative 10 times 54 plus 12. Negative 10 times 54 is going to be a negative 540. And then when you add 12, that is negative 528. So if I write this pattern all the way out to 54 terms, that answer is going to be negative 528. All right, we're going to move on to arithmetic series. Now, these are sequences. Now, arithmetic means you are adding and subtracting. Now, if the pattern is multiplication, that is not arithmetic. An arithmetic series means it's the sum of the terms of an arithmetic sequence. So now, instead of just the pattern, you're actually finding the sum. So you need to add up all the numbers. You have to add up all the numbers. And the formula here is going to be the sum of n, meaning however many numbers are in the sequence or in the pattern. And then it's n divided by 2, a1 plus an. That's first term, last term. First term, last term. Like, are we adding up the first 10 numbers? So then you get the first, whatever the first number is and whatever the last number is. So for this example, it says, find the sum of the first 30 numbers. So the first 30 terms of this sequence. Now, we kind of already did this one already. So let's see what we know here. We know that it's going down by 10. We know it's going down by 10. So the common difference is going to be a negative 10. I know that the first term is going to be the number 2. So we're finding the sum. We have this formula, S of n equals n over 2 a1 plus a to the n. Now right here, it says it wants to know the first 30 terms. So this means n equals 30. So now when I plug all this in, I have S of 30 equals n is 30 divided by 2. A1, I know what the A1 is. The A1 is the number 2 plus A30. I don't know what the 30th term is. I don't know what the 30th term is. I'm going to need to figure that out. So I don't know what A30 is. What I do know is that the formula is to find any number term, I'm going to use explicit, is an equals a1 plus d times n minus 1. I need to use explicit to find out what the 30th term is. Otherwise, what you can do is this is the first term, that's the second term, that's the third term, that's the fourth term, that's the fifth term. You can keep going and subtracting by 10 till you find the 30th term. However, your margin of error is going to be really high because you might mess up when you're subtracting. So I'm going to find the 30th term using the explicit formula. A1 is going to be the number 2. The common difference is the number negative 10. N is going to be a 30 minus 1. Order of operation says do parentheses first. 30 minus 1 is going to be a 29. Next, I'm going to multiply. So negative 10 times 29 is negative 290. And then 2 minus 290 is going to be a negative 288. So that is your 30th term. So if I write out the first 30 terms, it's going to start with 2 and it's going to end with negative 288. So I have to plug the negative 288 right back in there. So I have S of 30 equals 30 divided by 2 is 15. 2 plus, now A30, I found that to be a negative 288. Order of operations says do parentheses first. So that is a negative 286. And then 15 times negative 286 is a negative 4,290. So if you add the first 30 terms of this sequence, you are going to end up with negative 4,290. Summation notation. On summation notation, this is called the summation symbol. Now, the number on the bottom is going to be where you start at. The number on the top is going to be the number you end at. And then it's going to have the equation right here. So the number on the bottom is where you're going to start at. So you're going to start at n equals 1. The number on the top is where you end at. And then this right here is going to be your equation. So basically, you're going to starting with the first term to the 10th term. What is the sum using equation 2j plus 5? So if I asked you for this right here, I'm asking you to find the sum. This is the sum formula. S of n equals n over 2 a1 plus an. Now remember, you're ending at 10, so your n is going to be a 10. So this is going to be S10 equals 10 over 2 a1 plus a10. Now, in order to find a1, you have to actually plug it into the equation. So to find a1, that's going to be 2 times 1 plus 5, which is going to be 2 plus 5, so that's 7. So the number 7 is going to get plugged in there. And 10 divided by 2 is 5. And then to find the a10, I have to plug 10 into there. So then that's 2 times 10 plus 5. That's going to be 20 plus 5 is 25. So I'm going to plug a 25 there. Order of operations says to do parentheses first. So S of 10 equals 5 times 32. And then 5 times 32 is going to be 160. And that concludes our notes.